we only did the general form of the examples where, the statement was in the symbolic form was given to us and we just had to create a table. So what I would like to do today is actually look at some examples that are, given to us as a statement, and then we are having to put that in symbolic form. So let's take a look at a couple examples with that over here. So let me see, how about, let's do number 22 from here. So this one is basically saying, if you look at the instructions, they're saying, translate the compound statement into symbolic form and then construct the truth table for the expression. Okay, so let's take a look at number 22 over here. So they're saying if the lyrics are not controversial, the performance is not banned. So basically, first we have to come up with our, P, Q, and R statements, and then we have to put it in the symbolic notation to try and see, okay, which truth table we need to create. So is this going to be conjunction or disjunction? A conditional statement, or is it going to be, is negation going to be a part of that also? So if you had to define your P and Q statements in this case, what would you assign them as? And do we need more than two statements, or is two going to be enough? Okay, so Burgundy, you're saying the controversial lyrics part can be the P statement, okay? And performance being banned is going to be the Q statement. Okay, so let's take a look at this guy here. Alrighty, so let's see. Okay, so we're defining the statement P and Q first. So we are saying for the first one, the lyrics are controversial. And then for the Q statement, you can say the performance is banned. Okay, so how would you now put this in symbolic form once you define your P and Q statements? So what would your symbolic form for this statement look like if we are defining P as the lyrics are controversial and Q as the performance is banned? Okay, so Isabel and Burgundy, you guys are saying not P implies not Q. Yeah, because you've got negations on both of them there. The first part is saying the lyrics are not controversial, so that's definitely a negation on the P statement. The second part is saying the performance is not banned. So of course, again, that's a negation on the Q statement. Now you will see this is in the form of the if-then statement. So if always contains the antecedent or the first part. So the not P is going to be the antecedent and not Q is going to be our consequence. So yeah, you are going from not P implies not Q. Alrighty, wonderful. So once you have your P and Q statements defined. You have your symbolic form. Now let's create our table over here. So can you tell me what will be the different column headings for our table in here? So what would you have as your column headings on these? Okay, let me see. You've got P, Q. Yeah, we definitely need those. Then, of course, you need to do a negation on each one of these. So not P, uh, not Q. And then what else did you have in there? Burgundy. And then you're doing the final statement. Yeah, very nice. So not P implies not Q. And we'll need to go get that symbol in there. Alrighty, so let me see what your table comes out to be here, guys. And do you know how many rows your table will have based on what we discussed last time? Yeah, because you only have two individual statements. So when you only have two statements, remember we did 2 to the second power, which will tell us how many rows we are going to have. And of course, in this case, you're only going to have 4 rows. Alrighty, very nice. Okay, so remember your basic setup is going to be true and true for the first one, and then false and false for the last 2 rows. And then with the Q, you alternate each truth value. And then go ahead and complete that table and we'll compare what answers you guys come up with. So don't send your answers just yet. When I ask you to, you can send it. Hey dear Molly, I don't see you guys. Where are you? Oh, okay. All I see is a wall. I'm not seeing you though. And Adia, I see a ceiling. Alrighty, so of course you are negating the P and Q columns for the first 2, over here. So what is that P column negation of P going to end up looking like? Okay, Lorena, you've got false, false, and true, true. Okay, so that would be for our negation of P. Okay, and then when you are negating the Q column, what will we have? Yeah, this is where again you're alternating each. So now you'll be going false, true, false, true. Now remember, for the negation, that's what you will be using these 2 columns to try and complete our conditional statement over here. So looking at our conditional, and again, just to review this with you guys very quickly, when we are talking about the conditional statements, um, this is what you are looking at. So remember, with the conditional statement, every uh, possible case is going to be true, with the exception of when the first one is true, but the second one is false. And of course, in this example that we are looking at, we're definitely going in the order from left to right. So you are keeping this direction. So we are going from left to right when you're working with this. So can you go ahead and tell me what that column will end up looking like? Okay, so you've got false, false, which will still be true. Okay, let's see. The first one is false. The second one is true. So, and I'm just looking at the answers Burgundy has here in the chat. So that will also be true. This is where the first one is going to be true and the second one is false. So in this case, over here, you are going from the first one to the second one, from true to false. So this one actually will be false. And then the last one, both cases are true, so this will be true. So Aaron, it looks like you had false in the second answer. So here you're going from a false to a true statement. So that will actually still be considered a true case. So remember, it's going to be true if both the first and the second are true. If the first one is false and the second one is true, it is still true. If both cases or both are antecedent and consequent are false, our conditional statement is still true. So only in this case over here, the second one, where the first one is true but the second one is false, is where it's going to end up failing. So does that make sense why that second case would not be false? Okay. Okay, let me see what you guys are going to do for number 28 over here. Okay, good, Aaron. So I'm gonna let you work on number 28 and I'll give you about, what time is it right now? 10:19. So how about I give you till 10:23 to try and get this done. So no electric powered car is a polluter. Number 28. Just having car as P is not enough, Isabel. It's got to be more than that. So you actually have to figure out in what form is the sentence in and how would you go about writing it. Okay. Kiara, you are saying electric powered car, okay? And again, remember, it's got to be a statement. So kind of like we did in the previous example where we said the lyrics are controversial, the performance is banned. So it's got to be in a sentence, not just phrases. So make sure you would rewrite it accordingly. Okay, so I want you to start by sending your Q statements for this P and Q. What did you assign your P and Q statements? Okay, so again, Burgundy, it's got to be a statement. So just assigning P as electric car, how would you rewrite it as a sentence, as a statement? Okay, so I am looking for something more like this. Okay, so more like the car is electric powered. So now how would you write the Q statement then? Very nice. Yeah, exactly. Very good. Let's see, you want to define the car is electric powered. For Q, the car is a polluter. Okay, and then what is your symbol for this statement? No car is electric powered. Using these P and Q statements, how would you write it? Okay, so let's see, Burgundy, you've got P implies not Q because we are saying no electric powered car is a polluter. Now, if you remember, and this was from your 1.2 handout, let me see if I can pull that up really quickly. From our 1.2 handout, we had done the example very similar to these ones. Okay, yeah, right here, when they were asking us to translate our words into symbols. So example 6, if you look at that from your 1.2 handout, part B was where we had no snake is warm-blooded. So you can use that idea where we are basically saying you can rewrite or rephrase no snake is warm-blooded as if it is a snake, then it is not warm-blooded. So we can actually use that same idea here, and if you wanted to rewrite this statement, you can basically rewrite it as if it is an electric powered car, it is not a polluter. So you're basically using that form. So yeah, this will come out to be P implies not Q. Alrighty, so what does that table end up looking like? So go ahead and give me your column headings first. And if everybody is not going to answer, then I'm going to have to start asking you to send answers individually. So I would like all of you to participate. Right? So of course we start with our standard P and Q columns as the first one. Since we are negating Q, we have to have a negation, and then what else? Let's see, Markley. Okay, very nice. Okay, so P implies not Q. Okay, so of course, again, we start with our true, true, false, false for the P column. That's your standard. True, false for the Q one. Okay, so somebody who has not answered yet, let me see. Okay. Um, Becca, why don't you tell us what a not Q column would look like? Isabel, so you would need P implies not Q. You don't need P implies Q because that is not our final statement. Okay, so not Q, of course, you're just negating the Q column. So change the truth values. Alrighty, very nice. And then Cooper, what do you think our final column will be here? Are all of them going to be true? Is that what you're saying? Oh, okay. Actually, since this is an implication, let's take a look at this one over here. So Cooper, go ahead and send me all the remaining answers also. So this one is P implies not Q, which means we are using the P column and the not Q column. So of course you are again going from left to right. So the first one is true, the second one is false. So what does that mean our truth value is going to be for a conditional? It's not going to be true because anytime in a conditional statement, when the first value is true and the second one is false, you know, this guy here is going to be a false. Okay, Aaron, you've got false, true, false, true. Markley, you've got false, true, true, and true. So let's see, yeah, because again, this one is true, this one is true. So this will also be a true statement here. These are both false over here in the third row. So this one actually will still be a true. And then the last one, you have a false and a true. So this guy will stay true. So it's only the first one. So Cooper, you have to look at what symbols are being used in your final conditional statement over here. And this is only using P and not Q. So you only have to look at the columns for P and not Q. So Q has no bearing for this statement. So you always have to look at which symbols are being used in your compound statements that you're trying to figure out the truth value for. So it doesn't have to do in which order the statements are written, it's how it's written in the symbolic form. It doesn't matter how the columns are listed out. Alrighty, so looks like Macy, Rebecca, Maribel, Elizabeth, Lorena, Logan, Markley, you guys had the right answers. Looks like Aaron and Molly, you've got in that third row, you guys have a false, which should have been a true in that case. So, Aaron, you are saying why would the third row be true when both statements are false? Because remember, we had kind of talked about, since you haven't met the claim in the first part, so if you remember the example you have in your textbook or your handout over here was where we were talking about, if you give me $50, I will give you tickets to something, a ballet or something. Yeah, with this one over here. If you give me $50, I will give you tickets to the ballet. So what happens in where both statements are false? Basically, you are saying that you did not give me the $50. I did not give you the tickets to the ballet. So the claim that we are making was not false, because if you had given me the $50 but I did not go back and give you the tickets, that means I did not keep my end of the bargain, right? So I did not do what I was supposed to do. So that's what makes a statement false. But if the condition itself was not met and you didn't get the result, there really was nothing wrong that happened. So there was nothing false in the claim of the statement. So that's why when both of them are false, your conditional statement will still be true. Okay, let's see. Yeah, so Cooper, looks like you were asking the same question. So Aaron and Cooper, you guys had the same thing. Let's see, what was the one after that? So the columns can be arranged in any order. Yes, Becca, the columns can be arranged in any order. But then, like I said, you have to look at the final compound statement, and then you have to see which columns are being used. And then based on that, you would need to go, are you going from left to right or right to left, kind of like we had seen in some examples last time. Isabel, okay, you're saying you had the same question. Molly, okay, you saw where you went wrong. Okay, very nice. So just you have, and again in your homework, you have a couple different examples kind of going over the same, just helping you translate your words into symbolic form, and then of course creating your truth table. Now the next thing I wanted to look at here in section 1.3 was these idea of equivalent expressions. So basically they are saying, just as an example here, we're talking about when you purchase a car, the car will be new or used. So if the salesperson is telling you it is not the case that the car is not new, well then in what condition is that car? So if you actually look at it, we are saying it is not the case. So it is not the case is of course a form of negation that we use, and we talked about that in 1.2. And we are also saying the car is not new. So again, that is also a negation. So basically what happens in this case is you are taking a negation on a negation, which will actually lead you back to the original truth value. So you can just kind of see we have just one statement over here, which is that the car is new. We're defining P as the car is new. And then when you're taking two negations on that, kind of like we do in math, when you take a number that has two negative signs, the two negatives become positive. So you can kind of use that same idea. So look at this table right over here. We originally start where the P statement can have either a true or a false value. Now, when we take a negation on that, of course, you will change and get opposite truth value. So the true becomes false and false will become true. Now, if you take a negation again on that negated statement, then the false will become true and the true will become false. So you will see this column will have the same truth value as the first P column that you started out with. So anytime you are taking a negation on a negation, you are actually coming back to the original statement itself. So we define symbolic expression, equivalent expressions are basically going to be your symbolic expressions that will have identical truth values. So your truth values will be the same for each entry, for each corresponding entry. And we actually use this symbol to show when we're talking about our statements are equivalent. So just as some examples over here. Um, you can also kind of think of this as being, the way we would talk about the double negation being equivalent to the original statement. So here we are given an example 5. If I am a homeowner, then I pay property taxes. And we have I am a homeowner and I do not pay property taxes. Of course, they're asking us to figure out if these are equivalent statements or not. So we go ahead and define our P and Q as I am a homeowner for P and I pay property taxes is Q. And then we take each of those two statements, put them in symbolic form, and now you will see we're basically trying to compare these last two columns to see if they are going to be equivalent or not. And as you will, go through the uh, logical statements over here, you will obviously see that our two columns do not have equivalent truth value for every corresponding case. So of course, those two statements are not going to be equivalent. So they're just kind of talking about, notice that the truth values in the last two columns are the exact opposite. So you can see where you have a false, you have a true in the other column, where you have a true, you have a false in the other column. So they are saying whenever this happens, we are saying one statement is actually the negation of the other. So these two statements are not equivalents of each other. They are in fact the negation of each other. Um, so they're talking about how you can take the one statement and you can say it's equivalent to the negation of the second statement. And we had talked about some of these negations when we had looked at our conditional propositions in section 1.2. So we had kind of identified how those negations would work out. So that's kind of what they are laying out here for us. So they're talking about, statements that look or sound different may in fact have the same meaning. And in this case, they are talking about, it is not the case that the car is not new has the same meaning if you would just directly say the car is not new. Or they are saying if I am, it is not the case that I am a homeowner, then I pay property taxes. This will be equivalent or have the same meaning as I am a homeowner and I do not pay property taxes. Now, again, remember, guys, we are not talking in terms of, in English, this makes sense or not. If this is the way we would normally speak in English, we are just talking about how statements that can be written a little bit differently can end up having the same meaning, or like we saw over here, they can basically end up being negations of one another. So let's take a look at an example where we're talking about if statements are equivalent or not, and then we'll come back to our De Morgan's laws. So let's take a look at number 42 over here. And this one, again, your instructions are saying construct a truth table to determine whether each pair of statements are equivalent or not. So we're looking at number 42 over here. So again, take some time. I'll give you another couple minutes to work through this. So come up with what your P and Q individual statements should be in symbolic form, what each of these two statements here will be written as, and then, of course, what does your truth table end up looking like? So start by defining what do you think your individual P and Q statements should be. Yes, you're trying to complete the problem. So assigning the P and Q statements, coming up with the symbolic form, and doing the table. So it's up to you, Aaron, how you define the P and Q statements. If you want to do the first part, where it says the streets are wet, you can go ahead and assign that as P. It is not raining. Again, you want to kind of decide how you want to assign the Q statement. You can make the first one the Q, the second one the P. So it's entirely up to you how you want to define the P and Q statements. Okay, so do you have a conclusion if those two statements are equivalent or not? Okay, let's see. What did you define your P and Q statements as? Okay, very good. Okay, what are the two statements in symbolic form? The streets are wet or it is not raining. Okay, so looks like most of you went with the streets are wet for P and it is raining for Q. Okay, so for the first one, the streets are wet or it is not raining. What's your symbolic form? So I've got not P implies not Q. Okay, so that wouldn't be for the first one. Isabel, you've got P or not Q for the first one. Yeah, so you've got, oops, wrong place. So for the first one, you would have P or not Q. Okay, I have to make this one smaller. Okay, so P or not Q, and then you guys are looking at if the streets are not wet, so that's going to be our antecedent part, and that's of course not on the P statement. And then they are saying if then, so of course this is where we have our implication, so you would have your little arrow, very nice, and then we are still saying it is not raining, so that's going to be not Q. Alrighty, very nice. And looks like that's what most of you gave me. Rebecca, yeah, just be careful. You had no negation on the Q for the first part, to P or not Q, and then you should have negation both on P and Q for the implication. Lisbeth, Mary Bell, those two answers look good. Lorena, that looks good. Macy, let's see. That one also looks good. Alrighty, very nice. And Isabel, yours also looks good. Paul, yeah, that looks good. So now go ahead and tell me what your column headings will be and how many rows will you have. 4 rows, very nice. Okay, and what are those column headings? Okay, so yeah, again, obviously start with the P and Q, and then let's see, Maribel, Burgundy, Kiara, we're going with the negations, okay, not P, not Q. And then you want to do both of the statements, okay, so let's do P or not Q, and then we'll do this one, the implication in the last one. Okay, very nice. Yeah, so all the answers coming through, looks like most of you had that. Hey, very nice. All righty. So again, obviously just go ahead and set up your first individual P and Q column. So that will be true, true, false, false, and then true, false for the P and Q columns. Alrighty, let me see. Okay, Logan, why don't you give us the not P column? Very nice. So negating the P column, so that'd be false, false, true, true. Very nice. Lisbeth, how about the not Q? Okay, for the not Q column, Lisbeth, you're just looking at the Q and doing negation on that, right? So that means the true value will become false and the false will become true. So you should actually have false, true on that column. Okay, now we're getting into disjunction, and you are doing your disjunction between P and not Q column for the disjunction. So let's see. Kiara, you've got true, true, false, true. So with disjunction, again, let me show you that very quickly. There we go. So with the disjunction, remember the only time a disjunction is false is when both individual statements will be false. In every other case, it's going to be true. So let me verify your answer over here. So let's see, you guys have true, true, false, very nice, and true over here. Yeah, very good. So only when both statements are false is when this guy would have been false, otherwise it's true. Okay, and that brings us to the implication not P implies not Q. So here, for the not P implies not Q, you are of course looking at the not P and the not Q columns. So what will that be with the disjunction? Burgundy, you've got true, true, false, true. Aaron, Isabel, you've got true, false, false, true, true, true. True, false, false, true from Macy also. True, true, false, true. Maribel, Kiara, Markley, Becca, Lisbeth. Ethan, you've also got true, false, false, true. Okay, so remember with conditional, if the first one is false and the second one, sorry, first one is true and second one is false, that's the only time you have a false in your conditional statement. Go ahead and erase that actually. But everything else, I've got false and false over here, so this will actually still be true. I've got false on the first one, true on the second one, so that will be true. And then of course, both of them are true in the last case, so that will also be true. So it's only this one here where the first one is false and the second one is true that your conditional will be false. And you know, again, guys, we are going in the direction from left to right over here. So now remember, if these two columns come out to have the same truth values for each case, that is the only time we can say that the statements are equivalent. And you know, of course, as we can see over here, we have the same truth values for each of these cases. So yeah, we can say that the statements are equivalent. So they have to be having the same truth value in each condition. No, Burgundy's got to be the same rows. Yeah. Because for each case, it has to have the same truth value. I'm glad you asked that. Yeah, that's exactly what it should be. For each row, it should have the same truth value, not just the same amount of T's and F's. All righty, very good. Now, the next thing I wanted to look at was our De Morgan's laws. So let me pull up our notes over here. And De Morgan's laws are actually talking about, you know, how we can kind of find negations for these compound statements. So we have actually already seen, let me Yeah, so right over here, we saw that these two statements are actually negations of each other. So P and not Q is a negation of P implies Q. So in that same way, if we look at these statements over here, we're basically saying we saw that the negation of a negation is equivalent to the original statement, and that's this one right over here that we started out with. We also saw that the negation of P implies Q, the whole thing is going to be equivalent to P and not Q. So in that same way, we can actually come up with other formulas for negations, which would be, of course, equivalent to other statements. And this was actually, this I guess, was solved or proved by this English mathematician and logician, Augustus De Morgan. And there's just a little bit of, again, just a historical note here on George Boole. And as you can see, he has also been claimed as the father of symbolic logic. So he's done a little bit of work on that also. But here are the De Morgan's laws that we are interested in. And this is particularly with our conjunction and disjunction type of statements. So you will see when we take a negation on P and Q, of course, we're taking a negation on that entire thing. That will actually be equivalent to the statement where it's not P or not Q. So you can see when we are actually taking a negation on the entire P and Q value, it will be the same in meaning or equivalency as not P or not Q. And then, of course, if you will look at the second law over here, when we take a negation on the quantity P or Q, it would be equivalent to the statement not P and not Q. So you can kind of actually see this example over here. We are given the first part as it is Friday and I receive a paycheck. The second example is talking about you are crazy or I am crazy. You are correct or I am crazy. So let's take a look at this first one over here. It is Friday and I receive a paycheck. So we are defining P as the statement it is Friday, Q as the statement I receive a paycheck. And then of course, when we put it all together, we get P and Q. It is Friday and I receive a paycheck. So you can see when we take a negation on this statement P and Q, it should be the same thing. Oh, come on. As, saying basically it is not Friday or I do not receive a paycheck. So that would be equivalent to this statement over here. So just kind of showing you how you can come up with those negations. So this one over here, you are correct or I am crazy. So again, we are assigning P as the statement you are correct, Q as the statement I am crazy. So of course, putting it all together, you get P or Q. So when we take a negation on P or Q, that is basically going to be the same as writing you are not correct. So that's your not P. And I am not crazy. So that would be its equivalent statement in the negation. So De Morgan's laws, and you will actually see it has a little statement over here where they're saying you can easily verify that the left-hand side will be equivalent to the right-hand side by using truth tables. And so they're talking about, exercises 55 and 56 in your textbook is actually where they're having you do that activity to show that if you did a truth table and, came up with the column on a negation of P and Q, it would be the same truth value as if you did a column for not P or not Q. So they would end up having the same equivalent truth values for each case. So they're just kind of doing that as an exercise problem if you wanted to verify that these laws actually work out. So here we're just talking about, bringing all of our tables here together. So you can see we have our negation table for that first one. So this is just the negation. This one here is for our conjunction. This one is for the disjunction, and this is for conditional. And then they are actually talking about the negation statements that are equivalent over here. So these are the four that we just talked about and we went over. So just something as a summary, you can kind of look at this part to help you out. Now, how about this example over here? Okay, so let's look at the instructions first. So they're saying write the statement in symbolic form, construct the negation of the expression in simplified symbolic form, and then of course express the negation in words. So let's take a look at number 68 over here. So this one is saying not eating dessert is necessary for being on a diet. So of course, first you want to go ahead and assign what you want to call statement P as, what you want to call statement Q as, then put it in symbolic form. And then of course, we want to talk about its negation. So where would you start by putting this in the symbolic form? P and Q, what would you assign as your P and Q statements? Okay, so again, you are talking about eating dessert and being on a diet. So again, in sentence form, what would that look like? So not eating dessert is necessary for being on a diet. And you've got not P implies Q. You're assigning P as the eating dessert part. So if you want to put this in a sentence, you can say the person is eating dessert. For Q, that was on being on a diet. So again, we can say the person is on a diet. But then you are giving me symbolically, not P implies Q. Now remember the is necessary for. I should have that here, hopefully in my 1.2. If you look at this one right over here, when it says is necessary for, the first part is actually your consequent, which is the second part in the symbolic form. And the second part is actually the antecedent. So when you have the statement in the form of is necessary for, you have to switch around your statement. So it will actually be yeah, so this is where you would have Q as the first symbol, and then we would have implying not Q because that is the not eating dessert. So let me get my arrow over here, and then not Q. Okay, so if this is going to be our original statement, now what would its negation end up looking like? You know, which would of course then be, if we had to write the negation for this, you would basically be taking a negation on that whole entire thing. So what would that be equivalent to? Okay, let me see what you've got. Because Aaron, you are taking the negation on the entire statement. So since we are saying, okay, if the statement is not eating dessert is necessary for being on a diet, you are negating that whole entire statement. So that's why we're putting negation around both the entire statement. Q implies not P. So Burgundy, you've got it's either Q implies P or not Q implies P as your negation. Okay, let's go back to our handout over here. So look at this fourth condition where you have the conditional statement. So when you're doing the negation, you are looking at the first one, P stays as P, and you're actually taking a negation on the second part, not Q. So again, look at how the negation of the statement works out to be. So when you are doing that, let me go ahead and write that down over here. So you're basically looking at negation on P implies Q as being P and not Q. Okay, so again, just from here. So now using this rule, what do you think the negation should be for our statement? Okay, so Maribel, you've got Q and not P. Burgundy, you've got not P and Q. Lisbeth, you've got Q and not P. Okay. So definitely, you know, whatever is the first part stays the same. So in our case, we have Q as the first part, so that will of course end up staying as Q. Then we are going to change it definitely from an implication or conditional statement to an and statement. So that's going to be this guy over here. And then let's see, Aaron, you had not Q and P. Q and not P from Ethan. Okay. You know what? I'm going to bring our statement down over here. So we have not Q implies not P. And we're trying to find its equivalent. So if the first part, P stays as P, that will be the same thing in our case. This Q will stay as Q. But if you look at this one over here, you had a plain and simple Q, and we ended up taking a negation on that, which means for our example, you would have to bring this negation in and then keep this one as it is, which means you would have to actually have two negations. Now remember, there were no negation signs over here. You just had P and Q. So that P stayed the same, which is what we ended up doing. But then you are negating this Q over here. So since we are negating this Q over here, you will see we had no negation on the original Q, but then we end up negating this Q. So that's what we have to do. In our example, we had this negation already on the P, which means we actually had to bring in that extra negation from the definition itself. So when you clean this up and rewrite this guy, you will actually have Q and the not of not P will actually just end up becoming P, because now you are using this relationship from the first one where the negation of not P basically ends up becoming the original statement P itself. So we're actually going to be bringing in that rule. So our negation here is going to end up being Q and P. And if the same letters being used in different ways is confusing you, you can always go ahead and replace these letters over here with R and S and R and S, if that helps you, because these are just symbols, so you can definitely change them, but the idea is whatever is the first one over here stays the same. So our Q will stay as the Q. Whatever you had in the second place, you have to bring this negation along with it. So in our second place, we had a not P, so that's the not P over here. And then you have to bring in this extra negation sign, and that's what we end up doing. So that's why you are coming up with Q and negation on the negation of P. And then negation of P is going to be equivalent to just the original statement P itself. So that's where this ends up becoming our final equivalent statement to the negation on Q and P. Now, if you had to put it back into words, the Q and P, how would you write that down? So basically in words, what would you have for the negation on Q and P? Yeah, exactly. That would be the negation. Very nice, Burgundy. So the person is on a diet, which is what we had for Q, and they are eating dessert. So that would be the negation. So, again, use your homework to help you out with practicing a little bit of this, because, this will definitely take some practice. You will have to do a couple different types of examples before, you will feel comfortable working with these symbolic logic, of course, working out with the truth table. So definitely it takes a little bit of time to get used to this. So before we move on to the next section, I wanted to see if you guys had questions about what we did right now. Alrighty, let's take a look at our next section, which is going to be 1.4. Okay, so of course we're just still working with our symbolic logic. So let's take a look at our next section over here. So this one is talking about, okay, 1 minute. Cooper, that's fine, not a problem. We can definitely talk about that later. Alrighty, so coming back to on our conditionals, of course, we're talking about how conditionals are different from our conjunctions and disjunctions, especially when it comes to, changing the order of our statements. So they're kind of doing a comparison here with algebra, and, they're saying, we know if we add two numbers, x and y, it would be the same thing if we added y plus x, because our result would definitely come out to be the same. And that's because we know addition is commutative. So just by changing the order of our numbers, your answer doesn't change. So we're saying in everyday language, a realtor might say the house is perfect and the lot is priceless. And another one might say the lot is priceless and the house is perfect. So they're saying logically, of course, the meaning is going to be the same, because you are looking at, kind of like the same thing with our algebra example. We're looking at P and Q and P, where we change the order of our statements. So when it comes to conjunction or disjunction, honestly, the order of the components will make no difference as far as we are talking about the truth value for those statements. If you were to change the Q and P or make it, P and Q, the truth value is not going to change. With conditional statements, of course, we have to be careful about that. So let's take a look at this example over here. So we are given as our example, P is the statement you are compassionate. Q is the statement you contribute to charity. So they're asking us to write this in the if-then statement form. So just starting out with P implies Q. Of course, we would say if you are compassionate, then you contribute to charities. Now, if we change the order of Q implies P, then we are saying if you contribute to charities, then you are compassionate. So you will see in the first one, we are saying if you are compassionate, then as a result, you are contributing to charities. In the second statement, we are saying if you contribute to charities, then that means, you are a compassionate person. So, you can see it changes a little bit. Now, looking at the negations with the P and Q, we are saying if you are not compassionate, then you do not contribute to charities. So that's, bringing in the negation on each of those individual statements. Now, changing the order, we are saying if you do not contribute to charities, then you are not compassionate. So if you take each of these statements, obviously they're not going to have the same exact meaning. So this is actually where we're bringing in this idea of how you can actually have three different variations on a statement. So you can have a converse, an inverse, and a contrapositive. So converse is going to be, where instead of writing your conditional statement as if P, then Q, you actually end up writing it as if Q, then P. So that part B over here is what we would call as the converse of our original statement. So if you think of P implies Q as the original statement, then Q implies P becomes its converse. And this is basically where you're just switching the places of your consequent and antecedent. Now, if we are talking about the inverse statement or inverse of the conditional, so again, your original is if P then Q, then your inverse is going to be where we take the negation on not P and not Q. So we're not changing the order of the P and Q, right? We're still keeping P as the antecedent and Q as the consequent, but now we are actually negating each of those individual statements. So that's basically what makes it the inverse of our conditional statement. And as you can imagine, the contrapositive is where we make a negation, but then we also change the order of P and Q. So you are not only just negating, but you are also interchanging the order. So if P then Q, of course, ends up becoming if not Q, then not P. So basically what happens with a conditional statement, you will see how it will actually end up having just a completely different look to when we do these changing the order, but then also changing, the truth value from positive to a or from the original truth value to its negation. So just to look at that in terms of an example over here, we've got our statement as you do not receive the proper refund if you prepared your income tax, if you prepared your own income tax form. So of course your original statement is basically saying if you prepared your own income tax form, then you did not receive a proper refund. So that's basically our original statement. So when we're talking about the converse, remember this is where you are interchanging the antecedent and the consequent. So just by rewriting it, your converse would basically end up becoming if you do not receive the proper refund, then you prepared your own tax form. So you can kind of see how that ended up changing for us. With the inverse, this is where you just keep the P and Q as it is, but just make a negation on them. So your inverse will now be if you do not prepare your own income tax form, then you receive proper refund. Now you will notice we already had a negation in the original statement because you already had that not, you did not receive. So of course, when you're taking a negation on that, you will say you received the proper refund. So be careful, how we look at these examples. Contrapositive is the last one. Contrapositive, remember, you're negating and interchanging. So the contrapositive in this case will end up becoming, if you receive the proper refund, then you did not prepare your own income tax form. So these are just, ways of seeing how conditional statements can basically be rewritten when you are changing the order of your antecedent and consequent, and then, of course, bringing in negations with them. So let me take a look at our example for this guy over here. Okay, so let's take a look at number 4 from our homework. Okay, so this is section 1.4. Okay, so your instructions for example 4 are using the given statements, write the sentence represented by each of the following. So this one here, they're not exactly using the converse, inverse, and contrapositive, but you can basically see they are kind of bringing in, changing the order of the antecedent and consequent, and also bringing in the negation. So we are looking at number 4. So this is the example we are looking at, and we have to rewrite it by using these symbolic logic. So statement P is given to us as he is an artist. Q is given to us as he is a conformist. So if you had to write it in this first part, P implies not Q, how would you write that in words? Okay, let's see. All right, so Aaron, you have got if he is an artist, so that's the P part, very good. Then he is not a conformist. Kiara, if he is an artist, then he is not a conformist. Very nice, yeah. All righty. Alrighty, very nice. Now here we're changing the order, and then again you've got a negation on Q. So not Q implies P. Let's see, Markley, you have got if he is not a conformist, then he is an artist. Burgundy, Maribel. Alrighty. Okay, so now on the next part, they are saying not P implies Q. Okay, let me see what you guys are coming up with. If he is not an artist, then he is a conformist. Yeah, so in this case, you will actually see we are now putting a negation on the first part, but not on the second part. So we are saying if he is not an artist, and then we are, of course, keeping the second one as it is. So then he is a conformist. Alrighty, and the last one, let's see, you are saying if he is a conformist, then he is not an artist. Okay, good. So you can see, in the same way is basically how your converse, inverse, and contrapositive work. But of course, this was just kind of to get you started with this idea of how you're going to come up with your converse, inverse, and contrapositive. So I'm going to give you one example with that, and let me see what you come up with. Don't send your answers till I ask, till I ask you to. So here they are asking you to find the inverse, converse, and the contrapositive, and you guys are looking at number 6. If you have the necessary tools, assembly line is less than 30 minutes. Like I said, don't type your answers in, or don't send them in. If you want to type them, you can. Just don't send them till I ask you to. Okay, so if you have the necessary tools, assembly line is less than 30 minutes. So we're doing the inverse first, then the converse, then the contrapositive. So remember, the inverse is going to be symbolically where you keep the same order, you're just bringing in negations on P and Q. Okay, converse is where you're bringing, you're just interchanging your P and, oops, that should be, hold on, don't send the answers just yet. And the contrapositive, of course, is where you interchange and negate. So that would be the not Q implies not P. Okay, so I want the answer for the inverse first. If you have the necessary tools, assembly line is less than 30 minutes. So what will the inverse for this guy end up looking like? If you do not have the necessary tools, then the assembly line is not less than 30 minutes. Okay, if you do not have the necessary tools, the assembly line is not less than 30 minutes, and looks like most of you have that answer. Okay. So Ethan, you do have to use the if-then format, or at least have the if. You can skip writing the then, but you definitely have to have the if in there because these are all going to be conditional statements. So yeah, you do want to make sure you include that. Oops. Okay, very nice. I will go ahead and type that in if you will tell me what we should have for the converse. Okay, so let me see. You guys are sending in, if the assembly time is less than 30 minutes, then you have the necessary tools. Yeah, because this is where you are literally just switching your X and Y, sorry, P and Q values. So here, you would basically have, you know, trying to use shortcuts over here so I don't take so much time typing in. So if assembly line is less than 30 minutes, then you have the necessary tools. Alrighty. And looks like most of you had that for this one. And of course now the last part, which is the contrapositive, where it's in the same order as the converse, but now you are negating both P and Q. So what will that look like? If the assembly line, let me see, is not less than 30 minutes, then you do not have the necessary tools. Yeah, wrong place. Okay, very nice. So you can see not a very hard problem. Just make sure you are familiar with what the symbols for converse, inverse, and contrapositive look like, because just like you saw in this example, they're not going to give you the symbols for what inverse, converse, and contrapositive looks like. So that will be something you will need to know. So if you mess up any of those combinations, then, you know, of course, your final answer would come out to be incorrect. So just be careful, you know, when you are going through these types of examples over here. Now, this next part is actually getting into equivalent conditional. So when we're talking about, you know, equivalent conditional, just like we saw previously, we basically want to see, you know, out of the conditional statement itself, the converse, inverse, and contrapositive, which ones of these are actually going to be equivalent together. So if you actually look through this example, you will be able to kind of see which two statements are equivalent. So if you compare their truth values, you've got true, false, true, true, and that's going to be the same thing over here. So your conditional and the contrapositive are actually going to be equivalent to each other. And then of course, if you look at the inverse and the converse, you will see they are going to be equivalent with each other. So the converse and inverse statements are equivalent. And if you just look through the paragraph, you will see they're talking about how the conditional and the contrapositive are also equivalent. So this will be something, to kind of, again, keep in mind as you are working through. So the conditional and contrapositive are equivalent, the converse and the inverse are equivalent. So I'll have some more examples for us to work through this, to verify the equivalency. And then we will also be actually getting into our biconditional statements. We haven't actually talked about them yet. So that is another type of compound statement that we want to talk about. So before I let you guys go, I wanted to see if you had any questions for me. Okay, so keep in mind, okay, I've got a question over here from Becca, which is saying, how do you tell the difference between necessary and sufficient? Um, so, Rebecca, they're actually the same statement, but they are written differently, because with is necessary for, we actually put the antecedent first and then the consequence of the P. The Q value goes in the front, P goes in the end. But when we write is sufficient for in the words, P goes first and Q goes second. But symbolically, they are always going to be P implies Q. So they are always the same symbolically, but just in writing in words, you actually switch the position of P and Q values. Okay. All right. So I was actually going to mention that there is no class on Tuesday, the 15th, because we are having campus-wide convocation. So we're not having classes. So you guys don't have to be there. Of course, we have to be there. But as far as classes goes, we will be seeing each other on Thursday. So there's going to be no class on Tuesday, the 15th. So I will be seeing you a week from today. So have a great weekend, guys. If you have any questions, definitely let me know. And Cooper, I will send you a reply to the questions you sent me for homework, okay? All right, guys. No, I will change the date for homework, because again, all of these holidays are kind of messing up with our time schedule. So right now, yeah, definitely pushing the exam till not next week, but probably the week after that. Okay. Looks like that were some of the last questions that came. So Aaron, you're asking me what's the main difference between converse and contrapositive? The negation, because converse, Q implies P, and contrapositive is not Q implies not P. So you end up putting a negation on both the Q and the P statements.
Okay. Thank you.
Yeah, you're welcome. Any other questions coming up, guys? So yeah, homework is not due on Tuesday. For some reason, I was not thinking that 15th we're not going to meet. I was planning on definitely meeting and having class on the 15th, but I checked our academic calendar and we've got convocation that day, so no classes or meeting on Tuesday. Hey guys, if you have no other questions, then I will see you a week from today. Be careful. Stay safe, everyone. Bye-bye.
I hope everybody has a good weekend.
Bye. Thank you. Take care, Aaron.